Hello everyone, today I represent our group Internet of Things final project, which will be about the base water monitoring system. For the introduction, by applying our understanding of the Internet of Things, we have developed a water level indicator that harnesses the capability of ultrasonic technologies. Given the global urgencies of water scarcities, monitoring the level in reservoirs, tanks, and the storage unit is crucial for efficient resource management. Through the utilizations of Berkeley simulation, we have intricately designed and linked our system to the Blink platform. This unique fusion of virtual simulation and real-world connectivity promises to redefine water levels monitoring. So let's join us in this exploring the synergy between the Berkeley and Blinks, forging a path towards smarter, more accessible water management solution. Okay, so now let's look at the theory part. In here, you can see that there are the empty tanks and the full tanks, which the empty tank we have empty tank distance and the full tank we have full tank distance. For the empty tank distance, this shows the distance between the sensor and the bottom of the tank if the tank is empty, while the full tank distance will show the distance between sensor and the water level when the tank is full. This is our simulation model in the workweek. So in our simulation in the workweek, it will consist of first the ultrasonic distance sensor, which you can see on the top left, the blue ones, and the digital humidity and temperature sensor, which are the white one on the bottom right, and for the OLED display 12 interface. It is you can see on the it will show the percentage of water, which are 55%, and the ESP32 in the middle, and for the LCD display that will show you the temperature and humidities, and lastly two LED, which are the green and the red LEDs. Also, these are our simulation in the Blink's website, which in this Blink website we will show the gauge for water level in percent, gauge for humidity in percent, gauge for temperature in Celsius, label widget for distance in centimeter, and lastly the toggle widget for print the values in the workweek. And this is our setup in order to link our workweek with the Blink website. Which first we have to update our Blink template ID, the device name, and the auth token to our Blink device, which you can get this from the Blink website, which depends on your device computers. And also you have to enter the Wi-Fi credentials, which in this case we will use workweek guest. Next, for our methodologies, as you can see that from the previous in the theory that we have an empty tank distance and full tank distance, we will be using in our simulation to set in here as empty tank distance, set it to 70 centimeter, and set the full tank distance to 30 centimeters. And for this one, we will set our trigger percentage, which the trigger percentage will define a trigger value in percentage, which we set the water level to 10%. Alarm will start when the water level drop below trigger percent, which the green LED will appear. So basically, this will alarm you when water in the tank are very low. So it will alarm as the green LED appears. Next are for the include and the define part, which in here we include various external libraries that provide functionality for different components and communication protocols, such as library for DHT temperatures and humidity sensors, controlling OLED display, LCD and OLED display setups, connecting the ESP32 to a Wi-Fi network, and for various pin definitions. Next, we will have some variable declarations and the Blink and the button configurations. And next, for the void check Blink status, in this it will function as it will return to true if the device is connected and false otherwise. And for the void display data, it functions to clear content display in OLED screens and update the information with specific text size cursor positions and print the values. Next are the void measure distance. It is an ultrasonic sensor measurement. This will function integrate the ultrasonic sensor to measure distance, calculate a water level percentage, update display, and trigger action based on the measure values. Okay, and next for the setup function. The setup functions perform the necessary setup tasks, initialize sensors and display, and prepare the system for regular operation in the loop function, which are the next parts, which are the loop function. In this, for the loop function, this is where the main logic of program resides, handling sensor measurement, blink communication, and updating display. And continue from the loop, we will have the void since DHT data, which this code function as to ensure that valid temperatures and humidity data are reached from the DHT sensors, and then send this data to the specific virtual pins in the Blink app. And also in the Blink app, you can use the widget connects to this virtual pin to display real-time temperature and the humidity informations. Okay, and next for the Blink Connects. The Blink Connects, the purpose for this code is to ensure that the device and the Blink server have consistent data for the specific virtual pins. And then lastly, the last part, we will have motion sensor handling. This part of code will allow you to monitor and respond to the state of the motion sensor in your Blink app. Okay, and for the results, the simulation in a workweek will show you the temperatures, the humidities, and the amount of water in tank, as you can see displayed in both the OLEDs and the LCDs. And for the first case, are the case when the water of the tank are below 10%, which you can see that the green LED will appear, and you can see from the display screen that it's only 5%, so the alarm with green LED appears. Also in the workweek will show you in the text below the simulation that if you say that water level is too low. For the second case, in the case when our tanks are overflow with waters, which you can see that it indicate in the percentage that it are beyond 100%, which in this case 125%. So the red LED will appear showing that the water level is too high, and also it will indicate in the workweek texting workweek that below the simulation that the water level is too high. And this is how it looks when we connected the workweek with the Blink website. As the information will be the same that show in the workweek and show in the Blinks, but the workweek will not print the result show in the texting below the simulation because we didn't toggle. We are in a toggle off situation. But if we toggle on, it will show the detail of the humidity, temperature, and distance as shown here. The humidity, temperature, and distance. Okay, in conclusion, our project leveraged IoT knowledge to create a water level indicators using ultrasonic sensors. We have designed a simulation models in workweek, link it with Blinks, and incorporate LCD and OLED display for real-time insight into temperatures, humidities, and water percentage within the tanks. This sophisticated system empowers users with comprehensive data for informed decision-making. Additionally, the simulation features proactive LED signals, with green indicating low water level and red signaling potential of the overflow waters. The adaptability of this simulation to real-life scenario is further enhanced by its compatibility with readily available components. Thank you.